Let's take a look at a firm in a perfectly competitive market. Regardless of market, however, a firm is going to want to maximize profit. Now, profit is equal to total revenue minus total costs, and total revenue is found by multiplying price times the quantity produced. Now, in a perfectly competitive market, price is determined by the market, and this is because there's many buyers and many sellers, so no one buyer or seller can set price. Now, our costs are equal to the average total cost times quantity. Average total cost is made up of our fixed costs, and fixed costs cannot change in the short run. So on that note, the short run is the time period in which all costs are fixed. So this means if we have equipment, we've got depreciation, and so that's a fixed cost, or perhaps we're in a long-term lease of a building. In the long run, however, this is when all costs are variable, or that is we can sell the equipment or our lease expires. So this also means then in the long run is we can change our production process because we can switch out our equipment or our location. Now the average variable costs, they can change, but they only change when quantity changes. So this leaves us with Q, meaning that a perfectly competitive firm can only change quantity in order to influence its profit. And therefore the question becomes, well, how much should we produce? Now back to this long run. The long run, because you can change your production process, also allows a firm to exit one market and enter another. So let's take a look at a specific example. So the example we're going to look at is a fictitious company called Bucci. Now Bucci makes a drink, kombucha, and so we've got some information here regarding our explicit and our implicit costs, which provide us with the following weekly profit and loss statement. And we look at it and we say, hey, you know what? This looks like it's a pretty good little business for us. So we go ahead and start it. And we find the following costs. So on the left, we've got the number of cups that we sell. We've got our average fixed cost, our average variable cost, our average total cost, and our marginal cost, which is the cost to produce one more unit, which is the change in total cost divided by the change in quantity. And we've got our price. Now, price is set by the market, and it just so happens that kombucha is selling for $4.50 a cup. So our revenue is going to equal our price times our number of cups. Now, there's one more measure that's going to be crucial for us to determine the profit maximizing quantity. And this is a measure called marginal revenue. So marginal revenue is going to be the change in revenue divided by the change in quantity produced. So for instance, if we start at 0, we have 0 cups produced and we have 0 revenue. If we go to 400, now we have 400 cups produced and we have revenue of 800. So in this case, the change in revenue would be 1800 would be 1800 minus 0 divided by 400 minus 0. Now what we find is that the marginal revenue in each case is $4.50. Now this is only the case in a perfectly competitive market. And the reason is every cup we produce, because there's many buyers, we can sell it at that market price. And then we can determine profit by taking a revenue and subtracting our total cost, which I haven't shown here just so we keep everything on one screen. Now let's take a look at our graphs. Marginal cost, we can always find it because it's the one that declines below the average variable and average total cost, and then intersects the minimum of each of those and making its way up. Now this is our marginal revenue. The one below this is our average total cost. Then we've got our average variable cost and our average fixed cost. So the question becomes, what quantity do we produce that maximizes profit? So we can see by looking at our profit that occurs at 3,600 units. So let's take a closer look at that. So first off, like we said, profit is maximized when Q equals 3,600. The second to note is that profit is also maximized when our marginal cost equals our marginal revenue. This is the case for all firms. The profit maximizing quantity will be found when marginal cost equals to or is slightly less than marginal revenue. So the third thing to recognize is that, and again, this is only the case with a perfectly competitive market, is that price equals marginal revenue equals marginal cost. Now, looking at our graph, our price equals marginal revenue equals marginal cost is found where the marginal cost curve equals the marginal revenue curve, and we see at this point it is 3,600. Now just consider for a moment. Imagine if we were producing 3,200. Well, at 3,200, the marginal cost of $4.05 is less than the marginal revenue. So this says, hey, we can produce another one for $4.05. We can sell it for $4.50. So this means we need to increase our profits by increasing the quantity produced. Or imagine that for some reason we're producing at 4,000. At this case, the marginal cost is $4.95, which is greater than $4.50 of the marginal revenue. So this tells us, wait, we're losing money, therefore we should decrease production. Now let's look at it graphically. So imagine we're producing at 3,200 cups. So we find that the marginal cost now is less than our marginal revenue. So this tells us that, you know what, we should increase production. Or imagine for some reason we're producing at 4,000. At 4,000 we see the marginal cost is higher than marginal revenue. So cost is higher than our revenue. So this says, oh, we should produce less. And again, it'll push us back to the point where marginal revenue equals marginal cost. And that is going to be the point in which maximizes profit.